afternoon, everyone. Welcome to APNIC eLearning web class. Today is Wednesday, the 26th of March in 2014. It's already 4:30 in the afternoon from Brisbane in Australia, where I'm broadcasting this class. Essentially, we do have 4 classes, 4 sessions. All of them are running for 1 hour every Wednesday, and this is already the last and 4th session. Now, the topic that we're covering is about best practices in managing internet resources. So as you can see from the title itself, we will be identifying what are internet resources before we can actually look at how we can effectively manage them. Right, so that's what we're going to do in the class. I'll have a more detailed overview just a few slides from now. Now, before we do that, I'd like to also introduce myself. My name is Cheryl Hermoso. I work as a training officer for APNIC. I work with a training team, and we do offer face-to-face workshops, tutorials, trainings, and if, of course, we have a very big internet community in our region, we cannot always go to all the economies, all the places, even if there is high demand, and so we have e-learning courses such as this, just to complement and to give opportunities for those that cannot attend our face-to-face workshops. Now, this class will run for 1 hour, as I've said, and just a reminder that towards the end, I will be asking you to fill in a survey for me. I will also post a link to that survey, and hopefully get some insights from you on the quality of the class, and also if there are other things that you might want in the future, maybe other topics that you're also interested in, then that's the way that you can tell us about it. Alright, so we have a lot of things that we want to cover for this session. We have a very limited time, but we will be looking at internet resource management. Okay, when we say resources, internet resources, we are talking about the number resources, because I'm coming from an RIR, a regional internet registry, whose main function is to distribute IP addresses and autonomous system numbers in an effective way based on the needs of the community. So how do we actually effectively do that? We will look at that. We will look at the objective. We will look at some of the goals. We'll look at some of a bit of history, essentially, of IP addressing that leads us to coming up with these objectives and coming up with some best practices. There are terminologies that you need to be aware of: allocation and assignment, portable and non-portable, so we will define them. We will look at some of the practices when it comes to IP addressing plan. How do you effectively do that? Based on the goals, how do we also aggregate them to before announcing it on the global internet? We'll look at address assignment both for v4 and v6, and then we'll look at the other number resource, which is AS numbers. Okay. We'll just briefly introduce you into that and how you can get resources from APNIC when it comes to that, and then we'll get into reverse DNS. Okay, managing reverse DNS. Once you have your IP addresses, how do you now create a reverse DNS and also reverse DNS delegation and things like that. Okay, and then at the end, some tools that can help you to do all of these things. All right, so it seems like a lot. Actually, there is a lot. It's just basically a combination of some of the main things that you think of it as a checklist that you will need, okay, to get your number resources. Well, let's begin with IRM. Okay, when I say IRM, that's Internet Resource Management. Let's look at the objectives. Why do we have this? It's basically because of these 3 things: conservation, aggregation, and registration. As I've said, APNIC is a regional internet registry. We provide, and we distribute these number resources from a central pool. Okay, it's coming from IANA, the Internet Assigned Numbers Authority. It's delegated to all the regional internet registries. We have 5 of them around the world, and it's based on regions. So if you need a resource, what do? You come to a registry. You come to APNIC if you are coming from the Asia Pacific region, right? So whether it's IP address or whether it's AS numbers, that's how we go about the process. But whenever we do these requests, okay, we'll have to look at these objectives. Okay, This is in effect by, of course, APNIC and the RIRs. And if you are also going to sub-delegate, okay, your blocks, let's say you're working as an ISP, you have customers that wanted to get IP addresses from you, then you also must take into account these objectives. Okay, first is conservation, which is essentially the efficient use of resources. Whenever you request for your IP addresses, it will ask you for a justification. It will ask you whether you actually need this IP address in the near future. Okay, it's not like, hey, I need my IP address in 10 years time, can you give me an IP address block? It's not like that. It has to be based on demonstrated need, and you should need that IP address block in the next year or the next couple of years. That is because we want to conserve IP addresses. Why? Because if you look at IPv4, we are already running out of these addresses. I'm not sure if you are familiar, but in the early days, we're using classful addressing. And with classful addressing, that means we are only giving large sizes. Okay, there are 3 classes available: Class A, Class B, and Class C. And we actually, the way that we're distributing them is, if you look at it from our current situation now, it seems wasteful. Okay, that's because they're giving very big amounts, very big blocks, and they only need maybe a couple, maybe not even 10% of those blocks. Okay, but we did not foresee that we will be having like an internet as big as we have now, and so we are at a point where we don't have enough IPv4 addresses anymore. And so with that, we have to think of a way to actually conserve these IP address blocks so that more people, more organizations, more networks can then still use the internet. The internet will still grow, right? So conservation, efficient use of resources, and how do we make sure that's possible? By implementing rules and policies that checks that you actually need those IP addresses. The next objective is aggregation. It's limiting the routing table growth. How is that? What is aggregation in the first place? If you have several blocks, let's just say that you have /24 blocks. Say you requested for a /22 block from APNIC. You gave those /22 to 4 of your customers. Each of your customers now has a /24. Now, in routing, okay, if you have an IP address block, if you want to be reachable, you have to announce them. And then it is announced on the global routing table. Okay, so it's just like a listing of all the IP address blocks and how to reach the networks that are announcing those blocks. That's your routing table. Now, currently, when you look at the IPv4 routing table, there are about 450,000, if I'm not mistaken, around 450,000 prefixes in the global routing table, and that is a lot. Now, if you have, going back to our example, if you have, let's say, 4 customers, you gave /24 blocks to each customer, what you can do is aggregate them, okay, combine these adjacent blocks together, and then announce it as one prefix on the internet. In that way, you are not adding to the growth of the routing table. Okay, so it's instead of 4 or maybe instead of 100 separate prefixes, you are just announcing one. That is what we call as aggregation or summarization. The third objective of IRM is registration. Registration is a means of giving information to the registry about who are the people or who are the organization that is holding these resources. IP addresses with autonomous system numbers are public resources. Okay, there is no means of ownership. So you get those IP address blocks, you renew it on a yearly basis. Now, when you do that, your details, okay, details about contacts, details about basically about the organization that's holding this resource will be recorded in a public database, which we call as the WHOIS database. This aims 2 things. Okay, One is to ensure uniqueness, meaning if you have an IP address, of course, if you use that IP address, it cannot be used by anyone else. Otherwise, there will be conflict, right? So it ensures that you are the rightful persons or the rightful network to actually use those IP addresses, okay? Next is it facilitates troubleshooting. How many of us, okay, maybe the network engineers, systems engineers, are doing maybe troubleshooting? If, let's say, I receive some random emails, spam, and I'm not sure where it's coming from, I wanted to find out. So I can use these resources, I can use the Whois database to find out the organization, the people that are in charge of this IP address block. So it does these two things, okay? More importantly, I think, is it ensures uniqueness. So these are the three main objectives: conservation, aggregation, and registration, and these are all equally important. However, it's not always the case that we can meet all of these objectives at once. So going back to conservation here, again, why do we have conservation? Why do we want this? One reason is IPv4 is running out. So we want to conserve, right? But what about aggregation? When do we usually aggregate? We can do that with IPv4, of course. But when we talk about, if you're familiar with IPv6, which is another set of IP addresses, okay? Let's say it's a very huge amount of space. Okay, it's much bigger than the IPv4 space. So if we don't aggregate, okay, if we choose to conserve, meaning we give away very small blocks, then we will have these many small blocks, okay, that will now be added into the global routing table. And the result is probably not as good because the routing table will grow exponentially. It will grow really, really big. So when you talk about v4, maybe your main focus is conservation, not as much on aggregation, although we want as much as possible to still aggregate. However, when you talk about IPv6, our focus is more on aggregation rather than conservation. Okay, we still think about conservation, but when we have to make a decision whether to aggregate or conserve, we will go with this other objective. All right, there are other objectives, such as uniqueness, fairness, consistency, but these three are the most important ones. So that's the three ones. Now, we've talked a little bit about the issue on IPv4 addresses. Okay, that is what we call as the exhaustion of the IPv4 address space. In 2009, IANA, which holds the entire IP address pool, has started giving the final /8 to all the 5 RIRs. So all the 5 RIRs now has a /8 block. Okay, IANA doesn't have any. And then some of these RIRs have started giving from their final /8. APNIC is one of them. I think even RIPE NCC has started giving also from their final /8. What is the implication of that for us? Okay, again, this is going back to conservation. Now, before, as long as you can justify that you need a block, let's say you have a very big ISP and you probably need a /19 IPv4 block. So you come to APNIC with all your documentation that proves that you will be using enough of these blocks to address your current network. Okay, that is possible. However, with the final /8 policy, okay, the maximum that you can request is now /22. It might be a lot smaller than what you wanted, but it makes sure that the entire internet still has, somehow is still growing. It still makes sure that some people, okay, some networks can still connect to the internet. They can be given a public IP address and they can still connect. Okay, that is what we do with the final /8. That's the goal of the final /8. So that's one of the issues that we are facing currently. That's why we have another set, which is IPv6. Another is the internet routing table growth, which, as I've said earlier, is the increasing number of IP address prefixes, okay, IP address blocks that are being announced in the global routing table. Now, if you're still using legacy routers, older routers that cannot actually receive these entire prefixes, you have workarounds of, like, to say, getting a small portion of that, and then all the rest will be using a default route. However, if you want to get the entire routing table, then it can be an issue when it comes to older or legacy routers. Okay, we know that over the past 15, 20 years, the internet has grown, has blown really, really big. There is tremendous growth in the internet, and it has an effect on the availability of the resources. That's going back to the IP address exhaustion that we've discussed. Now, to address this issue, okay, this issue actually has come up even early around the 1990s. Okay, that's when IPv6 actually became available. So I've told you about classful addressing, which is using class A, class B, and class C. We only work on 8-bit boundaries, and we are stuck on that. If we don't need, let's say, 65,000 prefixes or addresses, we will still get a /16. Okay, even if we probably need a lot less than that. So it's kind of wasteful. Okay, so good thing is that is no longer being used. That's already obsolete. We are using classless addressing, which is a more efficient architecture. In this architecture, we are not bound on octets, on /8, 16, and 24, but we can also use other bit boundaries in our address, so as we have just enough IP address space that is needed for our network. And why did we come up with this classless addressing? Again, that is to address the issue of wasteful addressing. Now, another is CIDR, which is essentially very closely related to classless addressing. So it's VLSM, or variable length subnet masking. That's classless routing. CIDR is now also using classless addressing in routing. So in routing, you don't, essentially, if you're using classful, if you have the IP address, you know what class it belongs. So CIDR essentially is an implementation that supports classless addressing. So that's one way, that's one practice. If you're still using classful addressing, I hope you are not. Okay, this is just the IPv4 distribution. This is the global routing table. Okay, it's an older graph, but if you look at CIDRreport.org, you should see that currently there will be around close to 500,000 prefixes. Now this shows us a lot of things. Okay, this shows us a bit of history of the IP addressing and how it changed over the years. So if you see at the start, when it started growing, we're still using classful addressing. The projected growth will be something like this. So it's a steep exponential curve. But when we started using CIDR and we started using classless addressing, somehow we have mitigated that. Otherwise, by this point, probably around 97, 98, we would have already run out of IP addresses. Okay, so CIDR addressing has somehow mitigated that issue. However, around 98 to 2000, again, this has somehow exponentially increased, and that is because of the boom of the internet. So many people, many even individuals or companies wanted internet presence. Okay, that's why it has grown. But after that, it is on a stable increase, which is what we like, up to the point where we are now, where we have close to 500,000 prefixes. It's still growing, which is what we want. What we don't like is to have just too many prefixes when we can actually aggregate them. Okay, so if you can, as much as possible, get back to that goal and remember to aggregate as much as you can. This one is the global routing table for IPv6. It's a lot smaller than IPv4. IPv4 have close to 500,000. IPv6 has just about 50,000, maybe 1/10 of the IPv4 routing table. However, the good thing about this is you can see this growth, which is quite exponential. If you look here, it's very, very small growth, but since around 2008 up until now, there is promise. You see that the IPv6 internet is growing, and therefore we can actually start moving and start using IPv6 as well. Now, as I've said, for us to understand better the different policies when it comes to internet resource management, there are two terminologies that you have to be used you have to understand. One is allocation versus assignment. How do you get your resources? How do you get internet resources? How do you get IP addresses? Again, the chain would be coming from IANA. IANA distributes that to the regional internet registry such as APNIC. Then APNIC distributes that to a local internet registry. When you say local internet registry, it is what we normally refer to as a service provider, an ISP. Okay? There can also be NIRs. Some economies in our region have national internet registries. Okay? And then from this NIR or LIR, it is distributed to maybe a downstream ISP, and then the endpoint will be the user, the customer. That is the chain. Okay? But that distribution is either an allocation or an assignment. Let's just say IANA to APNIC. That is an allocation. APNIC to the LIR or NIR, that is another allocation. NIR to a downstream provider, that is an allocation, but downstream to a customer is an assignment. If there is a direct APNIC member who is also a customer or end user, then the delegation from APNIC going to that customer is also an assignment. Alright, so notice that from here, APNIC allocates the members, a member allocates to a downstream, downstream assigns to the end user, and if you have an APNIC member, it also assigns to the end user. What do we mean by this? It depends on what you're going to use with the IP address block. If it is given to you and it is for further delegation to maybe downstream ISVs or customers, then that is an allocation. If you're not going to use it for your own infrastructure, that is an allocation. However, if you are now going to use it to assign to your servers, assign to your maybe to your computers, assign to your routers and switches, then that is an assigned address. Okay, so you'll see that properly in this diagram here. Okay, this is for v4 and v6. Okay, you got a /32 IPv6, and then you delegate a /40 IPv6 to a downstream ISP. But if it's assignment to your customer, then you give them /64, /56, or /48 customer assignments. I hope this is clear enough. Next is portable and non-portable. Portability is when you have an IP address block and you can switch ISPs all you want without changing your IP address block. So you can keep using your IP address even if you change your upstream providers. Let's just say if you're not happy with the service of your upstream, then you want to change to another one, then there is no need for you to renumber, meaning renumbering your services, renumbering your router addresses and all that. So that is the good thing about a portable address. Okay, a non-portable address is basically provided to you by your upstreams, by your ISP. So when you don't want the service from the ISP anymore, then you must return that back to the ISP and then get a new block from your new provider. So the downside to that is, of course, you need to renumber. Okay, you need to renumber because you have to return your old IP address block and then get a new one. However, this is actually what we do recommend. This is the only way to effectively scale the internet. See this diagram on the right side? So you have, this is essentially the same example that I gave you very early on. If you are an ISP, you have 4 customers. If these customers have their own IP address blocks, maybe they have their own portable IP addresses, and therefore they are not adjacent blocks, there is no way for you to aggregate them. Okay, so when you announce these prefixes, it will be announced separately. So that's just 4 customers. What if you have 100? What if you have 1,000 customers? So that's an extra 1,000 prefixes added to the global routing table. However, if you have a non-portable address, which is coming from the ISP, that is essentially a part of a big block. You give, okay, adjacent blocks to your customers, and therefore going from the ISP to the global routing table, you can just announce it as one big prefix. Okay, that's why it's more recommended if you look at everything from a big picture. Okay, it's the only way to effectively scale the internet. Okay, so that's the difference between portable and non-portable. So if you combine the two terminologies, you actually have a portable assignment, non-portable assignment, a portable allocation, and a non-portable assignment. Okay, so I hope that you can now identify, distinguish the differences between those four things. All right. So you now know how to request for your IP address. You now know which one is better, non-portable or portable address. Again, of course, it will still depend on you, depending on your topology. Maybe you actually need a portable address. If you're doing multi-homing, you're announcing your prefixes to two different upstreams, you are connecting to an internet exchange point, then most likely you will need a portable address. But other than that, okay, you might want to stick with a non-portable address. Alright, so you already know what to get or where to get your IP address blocks. What about planning for your addresses? Okay, once you get your IP address, these are the things that you need to do. Of course, you need to have a plan. Addressing plan is very important. You need to have an understanding of your network topology before actually assigning prefixes randomly to your network, so that you will avoid renumbering in the future. Okay, so you should be aware of your network, be aware of how your network is expected to grow in the next 6 months, the next 12 months, and possibly even the next 5 or 10 years. Okay, and from there you identify phases of deployment. Okay, what will change with this topology over time? Okay, what needs do I have? Do I need to set up redundant networks? Do I need to scale down or scale up? Okay, so basically when you're doing your address plan, first identify the components of your network. Okay, what are the parts of your network that you need to address? Identify the phases of the deployment that you are going to do, and basically what changes will happen over time, and also identify the equipment and any topology that will take place. Right? Now, all address space that are held should be documented. Now, let's just say that, of course, before you do your address plan, you have to check whether you have enough IP address blocks, right? If you're part of a multinational company, you possibly have a lot of IP addresses that are coming from different regions. Okay, if you have presence in different regions, they can request from these other regions as well. So when you do your request, let's say from APNIC for an IP address block, that needs to be taken into that needs to be accounted for. All right, you have to put in your documentation and everything. Okay, all the address blocks that you currently hold, even if it is gotten from another RIR, or maybe you've had that as part of a historical address even before we had the regional internet registries. Okay, so everything should be properly and well documented. There is a no reservations policy, as we've said. Reservation means that even if you don't need the IP address yet, but you foresee yourself needing it in the future, then you will start your request. Now, that is not allowed. Okay, again, going back to conservation, when you do your request, it has to be based on your demonstrated need. You should be able to use it over the next year or the next couple of years. Okay, so take these things into consideration, even if it's not you getting or requesting for address block from the RIR, but you now sub-allocating an IP address to your customers. What is sub-allocation? Again, if you're a registry, okay, or sorry, if you are an ISP, you have customers that needs IP addresses, so you provide smaller blocks from the big block that you've obtained from APNIC, right? So once you have these, okay, take into consideration our objectives. Can you assign big blocks to them? Well, there is a way to somehow regulate that, and that's what we call as the second opinion and also the assignment window. What is an assignment window? If you are a new APNIC member, you will have an assignment window of 0, meaning that every time you sub-allocate to customers, you have to consult with APNIC, meaning you have to request for a second opinion. In this way, APNIC can help you out, our host masters can help you out in deciding, okay, on or what to check, properly deciding basically before you give a block of space to your customers. That is a second opinion request. So over time, your assignment window will increase as you have more and more experience doing this. Okay, how about the size that you can give to your customers? There's no specific policy for that. Okay, you can assign based on your own policies. Okay, normally it will be something like /27, /28, /30, depending on the size of your customers. Okay, with IPv6, okay, again, there is no specific policy with regards to how much you can delegate to them, but there's one requirement. All /48 assignments to end sites must be registered. So most likely you will get a /32 block when you first request for your IP address. And then you have customers, you will give either /64, /56, or /48. That's just the normal, okay, normal things that we see being done in the community. So they have at 64, 56, or 48. Okay, if you are going to distribute /48s, make sure that it is properly registered so that in the future, when you need to request for another block, maybe you've run out, maybe you need more IP addresses, we can always check that those delegations and can easily prove that, hey, you actually have used this much space, and then you are now eligible to get your subsequent allocation. Okay, so just some things, some sub-allocation guidelines. Sub-allocate cautiously. If you're not sure what you're doing yet, if you're possibly new to this, you were given this task by someone from your company who has just left, then by all means, please seek an APNIC advice. We'll be very glad to help you out. Okay, and also we will be able to help you check the criteria whether your customers actually need those IP addresses. Make sure to efficiently assign and not be wasteful about these IP addresses. You know the history, you know the current situation that we have in terms of IPv4, and so to conserve, okay, to help conserve, please efficiently assign IP addresses. And the last is about registration, database registration. All sub-allocation and assignments, as much as possible, must be registered on the WHOIS database, because we know that apart from its use to evaluate if we need more addresses in the future, it's also a very useful tool for the community in doing things from troubleshooting, okay, to finding basically minute information about the owners of those IP address blocks. Okay, with IP address assignments, assignment, as I've said, is based on requirements. So this one is allocation, this one is assignment. Please know the difference. But same guidelines. It should be based on requirements. When you assign, never use classful addressing anymore. Use classless assignments. Okay. When it comes to IPv6 address assignment, I've shown you very briefly from the diagram that normally we give /64, /56, /48, right? Those are typical deployments. Why? Because /64 is the smallest that you can give in a small LAN. Okay, so you can't go anything smaller than that. /64 is the smallest that you can give in one network. Maybe if you have a customer that is a home user, then you give a /64. Okay, if you have something that's a little bigger, maybe you do /56. If you have a big customer that is maybe an enterprise company, a university, a government institution, then you might want to give a /48 because they are large in size. Okay, so those are the typical deployments. You can follow them. You can create your own policies within your organization. But typically, the reason we do such thing is because it's easy, right? It's easy. It's a factor of 4, and therefore it's easier for us to deploy it in such a way, especially with IPv6. All assignments to single end sites are usually /48s, okay? And also all POPs are eligible to get, or points of presence. Okay, so if you're an ISP, you have a POP somewhere that's deployed maybe somewhere in a remote country or province, then you can assign /48 with that. And if you have something that's like a big POP somewhere in the city, you can also assign /48 for that. So it's not dependent on the size of the infrastructure, okay, but basically each POP can receive a /48. So that is with IP addresses. Those are the practices that you can use with your with not just from requesting, but also for delegating those IP addresses and assigning that into your network, in your network topology. Next is on autonomous system number, or ASN. Again, ASN is the other half. Okay, they're also number resources, and you request for them in the same way as you do with IPv4. Very similar. So you also have public autonomous systems that you request from the RIR, or you request from your ISPs, and these ISPs will request them from the RIR in your behalf. Why do we need an ASN? An ASN uniquely identifies your network. So if you have a network presence, an internet presence, okay, and you are peering with other networks, then you will need a number, this number, an autonomous system number. So these are the requirements for eligibility to request for your ASN. You must be multi-homed, okay, meaning that you have more than one, okay, networks that you're connected to. Maybe you have 2 or 3 different upstream providers. Maybe you're doing direct peering with another company. Maybe you are also connected to an internet exchange point. In this way, okay, if you have this situation, you are eligible for an ASN. Okay. Also, if you are implementing some policies, filterings, okay, because you're connecting to different external peers, then you also probably need an ASN. So these are the 2 requirements for that. For you to request an AS number, there are 2 ways. One is, if you are an APNIC member, you can always come straight to APNIC and request for that. Again, these requirements must be met. Now, if you're not an APNIC member though, you can still request for an ASN, but that is through your upstream provider. The upstream provider is normally APNIC member, okay, and so they can request in behalf of their customer. Notice that we also have portable AS number and non-portable AS number. So similarly, a portable AS number is the one that you got from APNIC, and so you can use it even if you change ISPs. But a non-portable ASN is something that is requested through your ISP and therefore must be returned to that ISP if ever you change providers in the future. Okay, there is such a thing as transfers of ASNs as well. Okay, so please check if this is something that you are looking at. Then please check the documentation, the policy that is at the APNIC website. Okay, and yeah, it will give you more information on how to go about these transfers. Alright, next is on reverse DNS. So you get your IP addresses from APNIC, right? So once you have those IP addresses, there has to be a reverse DNS entry. Okay, in the same way that we do mapping for forward DNS, which is from the domain name to IP address, we can also do the reverse DNS, which is mapping of the IP address into a domain name. Okay, in that way, actually, reverse DNS is being used by a lot of applications to check whether a certain traffic is actually coming from the right source. So let's just say I sent you an email, and the email is coming from the domain, the mail server is domain example.com. Okay, now the server, the other mail server that received your email, can now do some checking. It will check the reverse DNS, whether there's proper mapping that. If there is none, this can add up into the value or a score of your mail. And if it reaches a certain score, it can be considered as a spam. Okay, so that's how spam scoring works. It checks a lot of things. It checks whether there's an attachment. It checks whether there are words there that can be use, if there are pictures, if there are basically a lot of things. And part of that is reverse DNS. It checks whether it can do a reverse lookup, and if it doesn't match, then it's possible that it's exposed. So that's one of the uses of reverse DNS. So in terms of managing these reverse DNS delegations, whenever you get your IP address block, APNIC will already manage, okay, a reverse delegation of the block that has been distributed to you. Okay, so there will be an entry on our reverse DNS. We maintain some reverse DNS servers here, okay, and it will be added to you. So in your case, if you're doing sub-delegation, you can also do the same thing. Okay, make sure that there is proper reverse DNS entries. Your main role as an organization is to be familiar with the process. Okay, if you are now, let's say you have a /22 block, but you're only deploying or using the first /24, then you want to create a reverse DNS for that /24. So you just familiarize yourselves with how it is done. It's very easy actually. It's just using the MyAPNIC database. You have to submit the block that you want a reverse delegation, and also provide information about 2 name servers. You have to maintain at least 2 name servers, okay, to handle that reverse delegation. Okay, so in that way we can minimize the pollution of the internet. Now there are many tools that can be used, but most of all, something that is centralized for all APNIC members is what we call as a MyAPNIC. It's a portal, it's a web portal, it is secure. Once you are logged in, you can see many things from details about your contact information, about your membership, and more importantly, information about your resources. Okay, what IP addresses have I accumulated so far? What are the AS numbers that I have requested? What are the delegations that we have? And even if you do DNSSEC, if you're doing RPKI, you can also see information about that in the MyAPNIC tool. Okay, so it's a very useful tool. So if you can, please try to check that out. That's myapnic.net. If you're not a member yet, you can always register, and then your corporate contact will approve it. Okay, once you are into the system, you can have a look at all your resources, all your IP addresses and AS numbers. Okay, and then you can do sub-delegations from there. Okay, so that's how you can effectively manage your the resources that has been allocated or assigned to you. All right, so that's essentially what we want to cover for these best practices. It's a combination of a lot of things here, but if we want more detailed discussion of each one, we have separate e-learning courses that tackles them mainly from a technical point of view. But this session is mostly just how we would effectively, okay, manage and distribute these internet resources. All right, so do you have any questions, Suba? Now, while I'm waiting for your question, if you are going to have one, let me just write the link to the survey. So if you have time, please fill this in as much as possible. We would like to hear from you whether this has been useful to you or not. I'm not very sure of your background, so if I have maybe introduced a lot of technical words in this session, you can send us an email to training@apnic.net if you want more clarification about that. But actually, we still have more time here, so if you have any questions, please feel free to write them down here. All right? If not, hopefully you learned something from this session. If you need help with managing your resources or requesting for new resources, please come to APNIC Help Desk, have a chat with them, or send them an email or give them a call. They'll be very happy to help you out. Send me an email as well, or the training team, if you have further questions about this class. Again, thank you very much, Suba, for joining me for this last session. I hope that it has been wonderful for you, and enjoy the